how transistors work. They're actually switches with no moving parts. So let's see now how a transistor switches on a coil. Ignition coils. The first type was the canisters type, and then we have a waste spark, coil pack, and now more currently we have the coil over plug. Let's take a look at this type first. Here's the diagram for this type of coil. This coil is illustrated by the gray box. You can see you have your primary and secondary windings both inside. And we have an exploded diagram here to kind of illustrate how this works. Now we need a power circuit, so we would actually have a power wire coming on here, and on this diagram down here it would be attached. On the electrical diagram you can see it coming in, so we've got our ignition battery plus going to the primary side of the coil. Now on the primary side you can see when it attaches down internally it splits off. One side has fewer coils and it's a heavier winding, and the other side goes to the secondary. So the heavier wire and fewer windings is the primary side. In the secondary side on the diagram we have power that is shared. The same power comes across to the primary and secondary. You can see that inside. They're both attached here. You have power to the primary and it splits off into the secondary. And it goes through the other windings. There's many more windings and it's the thinner wire for the secondary side, and then it comes out the tower, which is where your spark plug would attach. Now of course the circuit needs ground, so our ground would actually be attached here. This is where the ground wire would be attached. Now this power is here all the time, but the ground is only here when it is being given ground, in other words to turn the coil on. So the ground that's attached here is illustrated in the primary diagram here and the secondary right here. Now this coil, once it is energized and given ground, all of the current that was in the primary side goes into the secondary, comes out the tower, and it's looking for ground. The ground it's going to find will be the ground because it's screwed into the block. So your spark plug wire is going to come across, you're going to go through the spark plug, it's looking for ground, but it can't find it because there's a gap. We only have 12 volts, that's not enough to jump the gap. We need at least 10,000 volts or 10 kV to bridge this gap. Now here's an important thing to note. These are resistor spark plugs. So this voltage actually will come across here and it'll travel down, but there is an internal resistor. So remember in this diagram we had power going through the coil, so we have power going through the primary and through the secondary side. Power is going to come out, travel through the spark plug wire, go travel through the spark plug, but it has an internal resistor inside it. So the voltage actually won't make it past this because the resistor is going to resist that voltage. Now let's look at the newer diagram. These different types of coils basically have the same diagram, but there is one big difference. Let's look right up here at the very top. Now you can see it has disappeared between the primary and secondary. So our battery feed is to the primary only. There's no battery feed directly to the secondary. What we have at the secondary then is a ground. There's going to be ground and there's continuity through this wire. So let's look at this diagram. We have 12 volts to the primary side of the coil. So that voltage is going to travel down to the resistor and wait at the gate. It can't make it through because the gate is closed. The transistor is supplied power, but it's waiting for a trigger, and the PCM is going to supply the trigger. Power is always looking for ground, so we have a common ground that is going to share this signal. It's going to split off and go up to the transistor, and so we're going to have the transistor ground waiting at the gate. It's supplied ground, but it's waiting for a trigger signal. Now we also have ground coming over to the spark plug, and the spark plug is going to be grounded by being screwed into the block. Now the secondary side of the coil has ground, so we're going to have a ground wire all the way through. Now remember this internal resistor? That resistor is not going to oppose ground, So you would have ground continuity all the way through the spark plug. But you're not going to have any fire because we have no spark yet. So this transistor is our switch. It needs to be switched on, and for that we need a trigger signal. The ECM provides that trigger. So the ECM sends a signal in. Now that's going to be a ground signal. When it does, it's going to open the gate. That means power can find ground and current can flow. Once that current begins to flow, the primary side of our coil can begin to energize. If you're looking at this on a lab scope, you would see the coil being turned on and current beginning to build. Now, in order to generate a spark, we've got to get this current that's building in the primary into the secondary, because that's where it can travel to the spark plug. So the primary has to be turned off. Now, to get this spark plug to fire, we've got to get all this current that's building in the primary into the secondary, because that's where it's going to find the ground and fire the spark plug. So this primary needs to stop building, so that ECM will remove the trigger. When it removes the trigger, the gate will close. Power can't find ground. Current can't flow. All of this current was going to be induced into the secondary. Now I'm going to show this next part because it happens real fast, and then we'll actually come back and talk about it. So when the primary is turned off, all of that current gets shoved into the secondary side. Remember, the secondary had ground through it, but now that power found that ground, it traveled down that circuit. Now we've got 40 kV, 40,000 volts. That's more than enough to bridge the gap on the spark plug. The power can find the ground, make it ignition, and burn that fuel that's in the cylinder. Let's watch this again now in slow motion. Now, if you're looking at this with a diagram, you'd see the coil being turned on and all that current being built, and all of a sudden just be turned off, and all of that current's got to go somewhere, so it gets shoved in from the primary into the secondary. The primary collapses, voltage is induced into the secondary, all of that voltage travels to the secondary side of the circuit, it bridges the gap to find the ground, and gives us our spark. So that's how a coil works and how the transistor switches it on and off. So now we know how transistors work, how they turn on coils. So let's see now how to read all of that in a diagram.